Again, welcome back to C++ programming language course. This lectures cover the selection statement in C++, and our main objective is to cover the switch statement. In our previous lectures, we covered the one-way if statement. We also covered the two-way if-else, and also the multi-way if-else-if, else-if. Then we also covered the nested if statement. So again, our main objective here is to cover the switch statements and also the logical operators. Logical operators are normally used to combine two conditions. We have the AND and OR operators, which are the binary operators. Then we have the NOT operators, which is unary. So NOT operators is normally used to negate or complement a condition. So if a condition is true and we say not true, it means it's false. But N and O are, again, binary operators. We use them to combine two or more conditions. So we're also going to write expressions using the conditional operator, which is, again, close to if-else concept. So we start with the logical operators. Again, in C++ or Java, we have three logical operators: the NOT, which is the exclamation point, and also the 2%, no space between them, and also the vertical line, no space. So we have AND operator and also the OR operator. So the AND, again, is a logical conjunction, which means if we have two conditions, both conditions must be true in order to get a true output or to execute our statement. OR is disjunction. Disjunction means only one condition has to be true. Then our condition will be true also. Or if both conditions are true also, our condition will be true. But with AND, if one of our condition is true, we have false. If all of them are false, we have false. We only have true when all the conditions are true. With OR, we have false if all the conditions are false. So if one or all of them are true, we get true. So let's see the example here. Here we're going to use the truth table for the operator negate or not. So as we said earlier, if we have true and not true, which is not P, will be false. So if P is true, not P is false. If P is false, not P is true. So let's see the example here. Here they say assuming age is equal to 24 and the weight is 140. Now, if I say not age greater than 80, it will be false. Sorry, not age greater than 18. Because here, if it's false, because age is greater than 18, it's true. Because age is 24. So is 24 greater than 18? Yes, but we say not true. So not true means it's false. Now, if age is greater, that's what we are saying. If age is greater than 18, it's true. But not true is false. Here also, we say weight is equal to 150. But weight is 140. So that means this condition is false. But not false, we give as true. Because weight equal to 150 is false. Age greater than 18 is true. So not true is false. Now let's look at the AND operator. Again, the 2% means the AND operator. As we said earlier, the AND operator is a binary operator. So we need two conditions. So here we have P1 and P2. And our third column will be P1 and P2. So here we say if P1 is false and P2 also is false, then the output will be false. P and P2 will be false. Again, if P1 is false and P2 is true, P1 and P2 also is false. If P1 is true and P2 is false, P1 and P2 also is false. So P1 and P2 is true when P1 and also the P2 are true. So let's see the example here. Again, we have the age 24, the weight is 140. So we said, is 24 greater than 28? I will stop. If one condition is false, we don't need to check the second condition with AND operator. Because if one condition is false or both condition is false, the output is still false. So that's why, we don't need to check. So here they said it's false because what? Age greater than 28 and age less than 20 are both false. So if both of them are false, even if one of them is false, again, the output to be false. Now let's look here. They say age, which is 24 greater than 18. So that is true. And also 140 is greater than or equal to 140. Okay, so both of them are true. So this means our output will be true because both are true. Now let's go to the or. So with the or, we said that we only get false when both conditions are false. The rest will be true. So if one condition is true, we get true. So for example, P1 is false, P2 is false, we get false. P1 is false, but P2 is true, so we get true. P1 is true, but P2 is false, we get true. Both of them are true, we still get true. So here we have age, again, 24, weight is 140. We said 24 greater than 34. No, so that is false. Is weight less than 140? That's also false. So since both conditions are false, our output will be false. Is 24 greater than 18? Yes. So I will not even check the weight no more, because if one condition is true, the rest of the condition can be true or false. We still get true output. So here we still get true. Even the weight greater than or equal to 150 is false. But since age greater than 18 is true, our output is true. So again, 24 greater than 18 or weight is greater than or equal to 150. The output of both will give us again true. So let's see one example program here using the operators. So again, we have our library files, our main function. We declare variable name number. We enter the number is an integer. So now we are using the logical operator. We said that if the number modulus 2 equal to 0 and the number modulus 3 equal to 0, then we are going to print an output that the number is divisible by 2 and 3. So this means if I enter 4, yeah, 4 is true. 4 modulus 2 is 0, is true. But 4 modulus 3 is not 0. So this condition will not execute. Since we are using AND operator, both conditions have to be true in order to get an output. But here we have OR. Now, the same condition, if I enter 4, I will print this. So, but you can see that we are printing OR. 4 is divisible by 2 or by 3. So it can be one of them. But here we are using AND. Both conditions have to be true. So here 4 modulus 2 is 0. But 4 modulus 3 is false. It's not 0. Now here we say if number modulus 2 equal to 0 or number modulus 3 equal to 0 and number modulus 2 equal to 0 and number modulus 3 equal to 0. Then we say we can divisible by 2 or 3 or by both, but not both. Because again, here we are using the OR. And you can see that if this is true and this is true, but here, look, we put not. So that's why. If we remove the not, then it can be, but also both. Also both. But here we say not. So that's what make it, but not both. So we also have what we call the short circuit operators. And here we went through the concept. So for example, if I have P1 and P2, if P2, always I'll put for example, if P1 is most likely to be false, then I'll put P1 first. If P2 most likely to be false, then I'll put P2. Because in the AND operator, if one condition is false, it doesn't matter if I have 100 conditions, I'll still get false out. So that's why here they say C++ evaluate P1 and then evaluate P2. If P1 is true, but if P1 is false, then you don't need to evaluate P2. Because we know if P1 is false, doesn't matter, P2 can be true or false, they happen to be false. But if P1 is true, we want to check if P2 also is true, then we get true. But if P2 becomes false, then we still get false output. The same thing used by OR, P1 or P2. C++ evaluate P1 first and then evaluate P2. But if P1 is false, then we need to check if P1 is false, then we need to check P2. But if P1 is true, we don't need to check P2. So next is our switch statement. Our switch statement is almost the same as multi-way if, else, if, else, if. You can see we have a lot of conditions up to 4, 5. The difference is that the variable that we are testing, it's not good to use an interval. For example, I'll say it's greater than 90 or it's between 80 to 90. If the values is within interval, then it's better to use the if else next multi if statement. If else, if else, if. But if I'm checking a specific value, let's say if the variable is value is 80, I will do something. If it's 90, I will do something. If it's 20, so that would be a very specific values. So we start with this will be our variable name status. In C++, the word switch, everything lowercase, all the cases are lowercase. It's a keyword or reserved word. So the variable name is status. And here with K0 means if the value of status is 0, then we are going to compute as for single file. Then we break. Now it's very important to use the break here, because if we don't use the break, what will happen is that if the first case is true, we're still going to check the second case, third case, if there's no break. So this break allows us, if the condition is true, we break out of the switch. But if the condition is false, we go to case 1. So case 1 means we are checking if the status is equal to 1. If it's equal to 1, then we compute taxes for married, filed jointly. Then we break. So if case 1 is true, when we break, we come out of the switch statement. Same thing applied to, and also we always have what we call the default, which means if the status 0, 1, 2, 3, they are all false, then the last option, errors, invalid status, always print. Always print. So that's the concept here again. Status is 0, we compute task for single file, then we break. The status is 1, we compute task for married, file jointly, then we break. And the last default, we just do our default actions. And this example again, switch, and the switch expression. If the value is 1, we again execute the statements 1, then we break. If the switch expression, the value 2, then we again execute the statement 2, then we break, and we keep going until the default. So if any of the cases are, all the cases are false, then the last default will execute. So that's what we're saying here, the switch expression. Then we have option. It has to be one of these answers, value 1, value 2, or value n. If it's none, then we go for default value. Again, the keyword break make it possible for us to come out of the switch statement if the condition value 1 is true, or value 2 is true, or value 3 is true. If value 1, value 2, value n is false, then the default statement will execute. So example given here, we have a switch day. Now we say if it's case 1, Then we fold through to the next case. Case 2 all the way to 6. So here we are saying that if it's case 1, case 2, case 2, case 3, if it's any of them, then we're going to print, including case 5, we are going to print its weekday. So weekday will be Monday to Friday. So there's no need to put statement within, because if any of these cases execute, then we're going to print weekday, then we break. Other than that, we say it's a weekend. So it can be Saturday or Sunday. So that's the next case. We print and break. Now we also have what we call the conditional operator. So here we say if S is greater than 0, we assign 1 to Y, otherwise we assign -1 to Y. This is the same as writing this conditional operator. Also, Java supports this concept. So we have a condition here. If S is greater than 0, question mark, after the question mark, we have true. So if the condition here is true, we're going to print 1. If the condition S greater than 0 is false, we are going to print -1. So we have the question, after the question mark, if it's true, the statement will execute. If the statement is, the condition is false, then after the column will be the false section, negative. So that's the syntax here. We have the Boolean expression, question mark. If the Boolean expression is true, we execute expression 1. If it's false, we execute expression 2. Now, this is very good when we are, for example, I don't want to write if-else statement here that if num mod must equal to 0, the number is even number. And to write if-else inside the cout statement, it's not going to be nice to read. But using conditional operators, we can see how easy. So here, cout statement, number modulus equal to 0 is true, then I'll print num is even. If it's false, then I'll print num is odd. And that's the syntax again, Boolean expression. Expression 1 will execute if Boolean expression is true. Expression 2 will execute if Boolean expression is false. Now, next is how to evaluate 3 plus 4 times 4 greater than 5 times 4 plus 3 minus 1. In our previous Unit 2 lectures, we talked about, again, arithmetic expressions and operators. The same concept here. But here, remember, we have a relation operator. So we are going to compare the left value if it's greater than the right value. And also, we have something we call the enumerated types. Enumerated types, which sometimes we use the term enum, it's like a data type that you create. So the syntax is you use the keyword enum. My data type is day. And in the curly brace, open and close all the possible values that can enter into any variable I create that the data type is there. So the value can be Monday, Tuesday, Wednesday, Thursday, Friday. So now I will declare this even before the main function, right after the header file. That would be nice. Then inside main function, I will create a variable named day, but the data type will be day, which is the enum type day. In this case, I can only use the values in the curly brace for day. So here you can see example, we say Monday, we assign today, which is correct. Now, if you assign Sunday today, we are going to get error because there's no Sunday when we again declare the enum type day. We don't have input of Sunday. So let's see example of a program here, test enumerated type and see how we use it in C++. So as we said earlier, well, here we decided to declare it in the main function, but again, it's up to us. So we have our main function, we declare our type, day. These are all the possible items we can enter for the day. We tell a user to enter the day. We declare variable, and then user enter the day into the variable we declare. Now we are going to use the switch statement to check. So we say switch. day number. If user enter 1, which will be again Monday, then again we play soccer, then we break. Otherwise, if user enter Tuesday, we play piano. And in this case, we can see that the data type for day number is int. So number is 1, Tuesday will be 2, Wednesday will be 3, Thursday will be 4, Friday will be 5. And that's the values here. So again, that's how we use enum type or declaration. We start with the keyword enum and the name, and then the possible, again, values we can enter into that variable. And here we are checking the value we enter, whether it's what day it is, Monday, Tuesday, Wednesday, etc. So that will be the completion of these lectures. And again, hope to see you in the next lectures. Thank you.